Welcome to this one-shot video. In this video, we are going to talk about relations and functions for board exams. So what I'm going to do in this video is I'm going to take 5 different problem types that have been commonly asked in board exams. Take all the questions of previous year that has been asked in that category, solve those questions systematically, and cover all the board portions of relations and function in a very small amount of time. So without any wait, let us start with it. So if I look into the first type of problem, this is based on relations, types of relations. Now you can see that there are 3 important types of relations. The first kind of relations are known as reflexive relations. So there are even more types, but these are the 3 that are important. Now a reflexive relation is one in which A is related to A. This is one way to say it. Another thing is all A comma A should belong to relation. This should happen for every A that is present into it. Then another type is nothing but symmetric. What symmetric says is if A comma B belongs to R, then only B comma A should also belong to R. So you can see that the order of A and B is not important. That is what they're essentially trying to say. And the third type is nothing but transitive. What does transitive means? It says that if A comma B and B comma C, both of them belong to R, then it will be called as transitive if A comma C also belongs to R. Now, if a relation follows all of these 3 conditions, we'll call that relation as nothing but equivalence relation. And this is the question that is asked in different contexts in board exams. Now, let us look into the question that was asked in 2020. Now, in this question, they have given us a set, and all this relation earlier that we have talked about are defined from A to A. So they have given us a set A over which the relation is defined, and now they have given us the element. Now we can see that here the relation is being given in the form of ordered pairs, and what they're asking is basically which of these things are true. So if you want it to be reflexive, 1 comma 1, 2 comma 2, 3 comma 3 should be present. Others can or cannot be present. So 1 comma 3 might or might not be present. That is not important for reflexive. For something to become reflexive, 1 comma 1, 2 comma 2 and 3 comma 3 in this case needs to be present. You can see that all of them are not present, so it is not reflexive. If you look into the option, and this option can definitely be not true. This can also not be true. So A and C are the 2 possible options that can work out. Now for that we'll check reflexive. So if you can see 1 comma 2, there is 2 comma 1. So it is symmetric. And the reflexive we have figured out, it is symmetric. You can see that both the options talk about symmetric, so again it is not giving us an edge. But if I talk about transitive, what you can see is basically if we have 2 comma 1 and 1 comma 2, corresponding to that 2 comma 2 also be present, and this is absent. Hence it is not transitive. If it is not transitive, C option becomes true. It is symmetric but neither reflexive nor transitive. So this question is a very short question asked in 2020 in CBSE exam. Now if I talk about 2021 question, again you can see ordered pair based question is given to us, and what they are saying is which of the following ordered pair shall be removed to make it an equivalence relation in A. So out of this, which one if I remove, it will become an equivalence relation. So you can see that for making it reflexive, 1 comma 1, 2 comma 2, 3 comma 3 is essential. So obviously we have only one choice that can be removed, that is 1 comma 2, and that becomes our answer. Also because of this 1 comma 2, 2 comma 1, 2 comma 1 is not present, so it is also not becoming a symmetric relationship. That is one of the more reasons to remove 1 comma 2. So 1 comma 2 becomes your answer. If I move towards this 2018 question, this question talks about, you can see that now here instead of giving ordered pairs, what they have given to us is nothing but a relationship between A and B. So what they're saying is for all the numbers integers that lie between 0 and 12, so they're talking about 0, 1, 2 till 12. This is the basic A set that they have given to us. There is a relation that is defined between A and B in such a manner that A minus B mod, so this is the relationship, is nothing but a multiple of 4. So whenever this divisibility or multiple, this kind of a thing happens, we are going to use this kind of a relationship, and this will make your life extremely easy. Once you have done that, the first thing that we need to check is if I take an element A comma A, will it be a multiple of 4 comma 4 or not? If I satisfy on the left hand side, A minus A mod comes out to be 0, and that can be written as 0 into 4. So it is divisible by 4, there is no problem. So it is a reflexive relationship, there is no issue. If I move further, the next thing that I need to check is nothing but symmetric. So if I check symmetric one, what I'm saying is, if I assume a comma b satisfies that means a minus b is a multiple of 4, then what I need to check is, if this statement is true, then b comma a should also belong to R. If this happens, now from this statement we can also conclude that since it is a modulus sign, b minus a will also be a multiple of 4, and from here we can conclude that b comma a also belongs to R. In the third part, we need to check it for transitive. For transitive to happen, the condition is a comma b and b comma c. So if a comma b, this is a part of relationship, corresponding to that we can write a minus b is equal to 4n1. And if we say b comma c also belongs to the same relation, we can also write b minus c ka mod is equal to 4n2. Now what we are saying is, if we have both of these things, what we are saying is, now what should also happen is b minus c ka mod should also be a multiple of 4n. Now if you remove this modulus sign from here, then a minus b can be written as plus minus 4n1, and this is fine because if we have mod of x is equal to 2, that would mean n is equal to plus minus 2. This is a very basic idea based on modulus. If I write it for the next relationship, this can also be written as b minus c is equal to plus minus 4n2. Now you can see that what we want is a relationship between a and c. So we want to eliminate b. So in order to eliminate b, we can add both of these relations. So if you add these equations, what you are getting is a minus c is equal to plus minus 4n1 plus minus 4n2. And you can see that a minus c ka mod, if I put here, it will become mod 4, we can take out, plus minus n1 plus minus n2. You can see that this is an integer and it is a multiple of 4. So 4 is present there. So this relation tells us that it is also a multiple of 4, and hence your a comma c will also belong to R. So again, we started with the idea of a comma a, then a comma b and b comma a, then a comma b, b comma c, and a comma c. So this is how we can systematically prove such kind of questions. Now if I move further, there is this 2023 question that talks about relation R is defined in the set of real numbers as x comma y is such that x into y is an irrational number. Check whether it is reflexive, symmetric, and transitive or not. So first thing that we are going to do here is check for symmetry, reflexive. So what reflexive says is, if I take x comma x, it should belong to R. So if I am taking x comma x, and based on this relationship, what should happen is, if x comma x belongs to R, that would mean x square is an irrational number. Now what this, it is a set defined on real number. Now we can see that if I take the value of x as 1, 1 square will not be an irrational number. So this statement becomes false. And since this statement is false, this is not a reflexive. Now, when you are writing a board exam, it is very important to write the steps. So what I am saying, if you can write in terms of statements, you will likely get the right kind of steps that are required to solve a question. If I move towards the next part, that is symmetric. What I am saying is, if x comma y belongs to R, we need to check for y comma x. This is what we need to check. So if this is true, then what we are saying is x into y is an irrational number. So multiplication, so what we can say is y into x will also be irrational. There is no problem in this statement. So you can see that if x comma b, so that also implies y comma x belongs to R. From here we have proved this statement. So this is a symmetric relation, there is no problem. And in the third part, what we are going to do, what we are saying is, if x comma y for transitive, if x comma y belongs to R and y comma z belongs to R, we want to comment on x comma z. So from the first relation, x into y is irrational. From the second, what we can write is y into z is irrational. Now what we need to do is, basically we need to comment on the nature of x into z. Now we cannot say, this cannot be concluded from here that x comma z will also be irrational. Why? Because see, let us say that the value of x was 1 and the value of y was root 2. So 1 into root 2 came out to be rational. Same for the second case, it was 3. It came out to be rational. So you cannot say that 1 into 3 is irrational. So we can find an example wherein this condition is not getting satisfied. Hence, we can say that this is non-transitive. So what it turns out that it is not a reflexive. It is symmetric, but it is not transitive as well. So this is what we are getting. If you write these statements in a very correct order and do not miss out on to the steps rightly, you will get full marks in your board exams. If I move further, there's this 2020 question. It says that again, similar kind that we looked into earlier, 2 divides a minus b. It is defined over set of z. So what they have given is nothing but z. This is your a. So in order to check reflexive, what we are going to do is we are going to check a comma a and checking that if it belongs to R or not. So if you put a minus a here, it becomes nothing but 0. That is can be written as 0 into 2. So you can see that it is multiple of 2, hence this becomes reflexive. In the second part, in order to check symmetric, what we need to do is if a comma b belongs to R. So if I will have to assume it for a comma b. So what I can write is a minus b is equal to 2 times n. And from here we can write b relationship between b and a. And from here you can see that if I am writing b minus a is equal to 2 times minus n. It is a multiple of 2. And it is a multiple of 2, then b comma a will also belong to R. Second is also done. Now in the third part, what we can do here is we can move towards the idea of transitive. Now for that, if a comma b belongs to R and b comma c belong to R, then we can write a minus b is equal to 4 and 1. B minus c is equal to 4 and 2. Now our idea always in such type of questions is eliminate the b from both of these and get a relationship between a and c. So if again I add them up, and this technique we used earlier also, what we get is nothing but a minus c is equal to 4 and 1 plus n2. And from here you can conclude that since it is a multiple of 4, a comma c will also belong to. So what we have essentially proved is this relation that is given to us is nothing but an equivalence relation. Next is this question that came in 2020, and now you can see that a similar kind of question is asked. What you can do is you can pause this relation and try the same question, and it is not very difficult from the questions that we have just done. Now if I move towards this very important question that came twice, 2015, 2023, and multiple times might be in your pre-board etc. exams. It's a very important question. Why? Because till this point of time we were trying to figure out the relation type in a set A. Here we have, instead of that set, taken a Cartesian set. So what is happening is if you take a set of n cross A, in this ordered pairs will occur. So 1 comma 1, 1 comma 2, 1 comma 3, like this ordered pairs will occur. So what is happening is earlier it should be used to be one element. Now what we are taking is nothing but an ordered pair in the same kind of a situation. This is the first thing that you should understand in this question. The second thing is, now in all such kind of question, the first idea would be to simplify this relation that is given to us. So if I, in this AD B plus C is equal to BC A plus D, if I divide by ABCD on both the sides, you can see that this A and D will get cancelled out. B and C will also get cancelled out. And if I divide by BC, what I'm getting it inside is nothing but B by BC plus C by BC is equal to A by AD plus D by AD. Now we can see here that B will get cancelled out, C will also get cancelled out. So what we have is 1 by C plus 1 by B is equal to 1 by D plus 1 by A. So now what will you observe is, we have got a relation, but even what we can make it even better if we can somehow take A and C on the same side, because then the clear relation between A and C and B and C and D you will be able to observe. So if I rearrange, I will be able to write 1 by C minus 1 by D will be equal to 1 by A minus 1 by B. So now relationship becomes quite clear. What we need to do is this: the difference of the reciprocals. Now it is quite clear how A comma B is related to C comma D. So first understand this, because once you understand this, it is very simple question. In the third step, what we can observe is now the reflexive part first. Now for reflexive to happen, whatever is on the left hand side, that is a comma b, should be related to a comma b only. So here important thing is we have replaced that one element by an ordered pair. That is something new. So if I take this and simplify, if I put in my relation, my left hand side will become 1 upon a minus 1 by b will be equal to nothing but 1 by a minus 1 by b. So you can see that you are getting the same thing on both the sides. So it is correct. So it becomes a reflexive relation. Secondly, if I want to check for symmetric, how to do that? In order to check for symmetric, what we need to do is we need to say understand if a comma b is related to c comma d. What you need to check is whether c comma d is also related to a comma b or not. So based on this, what we have is nothing but 1 by a minus 1 by b is equal to 1 by c minus 1 by d. Now if I change the order here, what will I get is nothing but 1 by c minus 1 by d is equal to 1 by a minus 1 by b, and from here you can conclude that c comma d is also related to a comma b, and it is very simple to observe as well. If I move to the last part, that is transitive, how does it works out? So for transitive, our condition was that if a comma b is related to c comma d and c comma d is related to e comma f, then what we need to do is this two are also related. So let us write the condition for the first one. So 1 by a by 1 minus 1 by b is equal to minus 1 by c by 1 by minus 1 by d. If I write it for c, d and ef, 1 by c minus 1 by d is equal to 1 by e minus 1 by f. Now our idea would be to eliminate this middle terms, and it is very simple. We can equate and write here that 1 by a by 1 by b would be equal to nothing but 1 by e minus 1 by f. And now this is very simple condition, and from here you can directly conclude that a comma b will be related to e comma f. We have also proved that it has become transitive. If a relation is reflexive, symmetric and transitive, we can call it like an equivalence relation. So this was the first problem type based on reflexive, symmetric and transitive. Individual questions can also be asked. Objective questions can also be asked. In fact, JEE has also asked questions. But this board topic is very important. Largely, there might be a question based on this idea. Now, this next problem type is quite entertaining. That is nothing but based on the idea of domain and range. Now, what is domain? What is range? So if I take a function, whatever values are permissible to be put in the place of x in the function would be known as nothing but domain. And whatever values I will get out of it would be known as nothing but range. We can understand a very simple analogy. For example, you have a fan. So what we are saying is whatever we are putting inside as input, that input is electricity. So that is nothing but domain in this case. And what we are getting out of it is nothing but air or wind. And that is nothing but range. So it is a very simple analogy, anybody can understand, and this is something very basic and fundamental. I have not taken a very technical definition because it will cause you problems. And that will not be largely useful in solving problems. Now, in this question, that is 2014 question, it talks about a function and they are asking the range of this function. Now, what is the technique to find domain and range? So let us divide the discussion into two parts. First is domain. So mostly the questions that are based in board are based on two ideas, 1 by fx. Something like this would be given, or root of fx would be given, or both the ideas would be given. That is 1 by root of fx. So domain is simple to find. In this case, for finding domain, whatever is in denominator cannot be equal to 0. Solve this and get the answer. Whatever is inside the root that needs to be greater than equal to 0. Solve the inequality, get the answer. In the third part, both the condition will happen simultaneously. Apart from that, there is something also known as algebra. So if you have two functions which are either in addition, multiplication, division, whatever you are doing between them, important thing is if you want to find the combined range of this function, it would be nothing but intersection of these individual ranges. Domain will be nothing but intersection of these individual domains. Now this is very important to understand. Why? Because just by taking intersection of the domains, we can find the answer. So it is nothing very complicated. You can get it really fast. Now, unlike domain, range has a very complicated technique to figure out. But largely, The questions have been asked are simpler. So I'm going to discuss two questions using two different techniques. The first question talks about what they're given is nothing but x plus 2y equal to 8. What they're saying this is a relation of natural numbers. That means we are substituting only natural numbers in it. So it is defined from natural numbers to natural numbers. What they're saying is write the range of this function. So now what you can do is, if you want to find range, what we essentially want to find is the value of y, that is nothing but the output. So for that we'll write this as nothing but 8 minus x by 2. Now in order to get range, we are going to put the value of natural numbers in place of x and see what kind of answers we are getting. We also need to get the output in terms of natural number, because the codomain in this case is also a natural number. If I do this, what are the possible values of x that you can put here? So we can put the value of x as nothing but 1. And if I do so, the answer that I'm getting is nothing but 7 by 2. And 7 by 2 is not an integer, a natural number, so we cannot accept this. Then what I can put is nothing but x equal to 2. If I put x equal to 2, it becomes nothing but 6 by 2, that comes out to be 3. This is acceptable. Similarly, x equal to 3 will not be acceptable because answer becomes nothing but 5 by 2. And 5 by 2 is not a natural number. Next, if I move forward, what I'm going to get is nothing but, if I put x equal to 4, my answer becomes nothing but 4 by 2, that is 2, and it is acceptable. There is no problem with this answer. Then I can keep on doing this for 5. For 5, it becomes again 3 by 2, not acceptable. And for x equal to 6, what I'm getting is nothing but 1. Now, going further won't make any sense because it is decreasing, and after that it will become 0. And largely it will not be useful. So now what are the possible values of ranges that we could accept are these values. Corresponding to that, now you can also see that the value of the domain or the values of x are nothing but the domain. So what are the values that we are getting is 2, 4 and 6. So the domain for this question, though they have not asked, but if I want to write, can be written as nothing the possible values of x's, and that was nothing but 2, 4 and 6. And what is the range in this question? If I want to write those values, this is nothing but 1, 2 and 3. So this is direct substitution based question asked in 2014. If I talk about this 2021 question, it is based on graph. So for finding range, we can also use the concept of graph. The substitution technique might also be used because what they're saying is x and y are both integers. So substitution technique, what we learned now, can also be used. And then you can also use graph to understand what is going to happen in this scenario. So now let us see, and this is an objective question. So what method exactly you are using is unimportant, because what you need to do is get the right option correct. So now if I put the values, so what they're asking, what is the domain of this function? So range and domain both I will find. In this question, domain is asked, but range can also be asked in some other question. So let us do both. And you can see that both in this case won't be different because it is very symmetric functions. So x and y are interchangeable. So whatever we are getting as the value of domain will also become range. So now one method is nothing but, what you can do is you can draw this circle. Now in this circle, what you can observe is, because x square plus y square equal to 4 is a circle, what we want is the point that are inside it and on it. All of these points are fine. This we need to find. If I move forward, what are the such points? So you can see that if I start on this line, that is x is y equal to 0. This point would be nothing but -2. Then -1 will come, then 0 will come, then 1 will come, then 2 will come. You can see that what are the possible values of x that we are getting here is nothing but -2 is possible, -1 is also possible, 0, 1 and 2. All of these are possible values. So just in one line we have figured it out. Similarly, if I want to figure out the value of range, it is nothing but the values that we can get here. So again, you can write this as 1, and this point will become 2 itself, -1 and then -2. You can again see that same kind of values you are getting again. So your option B comes out to be true. Now another technique of doing the same question would have been to satisfy the values of the options in check. So what we could have done is taken the value of x equal to -2, because we are talking about domain now, and checked in the question. So if I put -2 in place of x, What we need to just check is whether we are getting some value of y corresponding to that or not in the codomain. So if I do that, y square will be smaller than equal to 0. That would imply y is equal to 0. So minus 2 is there in the domain. There is no problem. Let us also check one more value, that is nothing but 2. And if I do so, you can understand the things will not be very different. So the value of y comes out to be smaller than equal to 0. That would mean y is equal to 0. So what we can see that again, this is also true. So based on the options, you can see your option B becomes correct. So like this, option verification is also possible. Now if I move towards next problem type, that is based on nothing but classification of function. And these two classifications are asked a lot. This is based on the idea of mapping 1, and onto functions. Now first let us understand what is 1, function and what are the methods to do it. So 1, function essentially talks about a mapping. And this is also the first method of doing it. What we can do here is basically check the mapping itself. So what we are saying is, if the mapping is like that, if you have 1, 2, 3 and we have A, B, C, D here, so one element is getting mapped to one element only. It is fine if every element is getting mapped or not from set A to B. If I have 1, 2, 3 and A, B, C, that is also fine. There is no problem with this. But every element, one element is linked to only one element. This is important. This is the core concept. If I move towards the next technique, what we are saying is, if a relationship is given, then probably if I write it in this manner and solve, then I should only get x1 is equal to x2. Only is important thing. So this would mean, again, the function is 1, 1. Third technique is based on ordered pairs. So now let us say that in ordered pairs, A comma B is also given and C comma B is also given. So what is happening is, this A element is getting mapped to A and C are both getting mapped to. So many elements are getting mapped to one element. So this will become many one. So you need to observe these things in nothing but ordered pair. Then the fourth and little bit advanced technique is nothing but based on the idea of derivatives. So if we have f dash of x and this is greater than equal to 0, or what to mean is, if you have an increasing function, in that case also the function is 1, 1. Because if it keeps on increasing, corresponding to one value of x, there is going to be one value of y only. And now the fifth is nothing but using graph. Now let us say that a graph is drawn like this. So if I draw a line parallel to x-axis, if it is possible to cut it more than 2 points. If I draw a line here, obviously it will not cut. But if it is possible to draw one such line, then we are going to call this function as nothing but many one, because many points are mapped to 1 point. This is known as horizontal line test, because we are drawing a horizontal line to test the nature of function. Now let us move towards nothing but onto function. Now what onto function says is, if we have something like this kind of a scenario where all the elements are getting mapped in the set B. So now we are more focusing is towards set B. Every element is getting mapped. There is no empty element. This can also happen. And it can also happen in the format of many one. So 1, 2, 3, 4 is also there. A, B, C is there. So now this is also fine. There is no problem. But there, the codomain, whatever are the elements in the B that are nothing but called as codomain, should be equal to range. This is first. The second is, so what becomes the definition is nothing but codomain should be equal to range. So essentially it is also a question of range. Whatever technique is there is to find range, the same techniques will be involved here. So now let us say that another scenario is codomain is not given. Okay. So what you are going to do in such question is, you are going to assume the codomain as real numbers and then solve the question. Now other thing would be understand this codomain, find the range, then compare both the values. If the values are same, then we are going to say that the function is nothing but onto function. Now this 2020 question was given to us. In order to solve this 2020 question, what you can do is you can just make the arrow diagram and do this question. So if I make the arrow diagram, what I can see in the set A, what they have given is nothing but 1, 2, 3. In the set B, what we have is nothing but 4, 5, 6, 7. So what I need to do is, if I want to get this ordered pair 1, 4, 1 is mapped to 4. If 2, 5, then 2 is mapped to 5. If 3, 6, 3 is mapped to 6. So you can see that one element is linked to one element only. So it is a 1, 1 function. If I also want to check onto, you can see that not all the elements in the set B are, all the elements that are in range are there in codomain. So what we can say is, this is nothing but an onto function. So once you are able to make the arrow diagram, very easily you can tell the answer. But let us say that you do not want to use arrow diagram. Directly you want to do. So now in order to do, what you can see is basically, is your first element same anywhere else or not? It is not same. So one element is mapped to one element only, and the second element, none of them is same. So if the second element corresponding to any one element, so let us say that it had been 1 comma 4 and 2 comma 4 also, so the second element match corresponding to this first element. So in this case it will become a many one function. Now let us move on to this 2020 question. It is an objective question. Question talks about the function is given fx is equal to cos x, whether it is 1 1 onto or not. So in order to do cos x, it would make more sense to draw the graph now. So if I start from here, the cos x graph starts from my, it goes like this. So what we are saying here is that if I apply my horizontal line test and if I draw horizontal line, so it is cutting at many points, not just one point. So what we are saying is, if I am looking over the whole real numbers, there are many points, and this is also important where we are looking, where we are observing that nature. So what we can say here is that there are many points where this line will cut, so that this is a many one function. So this we have figured out. So now we can see that one more information they are asking whether it is onto or not. Now if I'm going till -1 2, so you can see that the codomain is also -1 to 1, and we all know that the range of cos x is between -1 to 1. So both of them are same. Based on this graph also, based on basic understanding also. So based on that, what we can say is it is onto. So onto part is fine. So it is many one onto. So not 1 1 but onto. So option B becomes correct. If I move towards next, this 2023 question, this again talks about this function 16 minus x square, and what they are saying is, so show that this function is onto but not 1 1. So now there are many ways to do it. Now I am using a different technique. I can also do using graph as well, but I am using another technique now. So what we are saying is f of x1 is equal to f of x2. Let us write this. So here I can write root of 16 minus x1 square, and this is nothing but root of 16 minus x2 square will come, and if I square it, it is 16 minus x1 square is equal to 16 minus x2 square. 16 will get cancelled out. So minus x1 square will be equal to x2 square. x1 is equal to either x2, this is one solution, or x1 will be equal to minus x2, another solution. Now this is what we are saying is basically this is definitely possible because -4 is also there, 4 is also there. So it is definitely possible. So what we are saying is this function is not 1 1 or many 1, because we are getting two conditions. Had we just got this first condition only, in that scenario we'll call it 1 1. But since we are getting two conditions, it is not 1 1. Now another thing that we want to observe is nothing but the onto nature. So for that we need to find the range of this graph. So in order to find range, what is the technique here? So now I can draw a graph. So if I take y here, it is nothing but 16 minus x square. And if I square it, it is x square is equal to 16 minus x square. So you can see that this comes out to be circle. X square plus y square equal to 16. So if I draw the graph, this is how the graph looks like. Now here, what is happening is, see, this is the graph of circle. We are not getting the whole circle here. We are getting semicircle. Why? Because if I do these steps in the reverse order, I will realize one more thing. If I start from here and start moving ahead, y square can be written as 16 minus x square. And if I solve further, y will become nothing but plus minus root of 16. So you are getting two answers here. So what I'm saying here, this top part is nothing but y is equal to root 16 minus x square. This bottom part is nothing but y is equal to minus root 16 minus x square. This is not us. So we do not want the bottom part. We just want the top part. So this is what we are getting. And if I draw the x and y axis, this is what this is origin. Since radius is 4 here, this will go till 4. This is minus 4 to 4. Now if you look into this, both the things can be proved. If I draw a horizontal line, it is cutting at 2 points, so it is many one. And now if I look into the range, so you can see that the value of y here will start from here and will go till 4. So your range is nothing but from 0 to 4, and that is equal to codomain. Your range becomes equal to codomain. This becomes nothing and onto function. And this earlier technique of expressing y x in terms of y x in terms of y, we can again use in this question. So what they're saying is they have given this function. What they want us to show that the function is 1 1 also and on 2 also. So let us use the technique. So first for 1 1. Now I am not using the graphical technique. I can use the graphical technique as well. I can also use the technique of derivative. That is also possible. And I can use the simple technique of f of x1 is equal to f of x2. And I'm using this because most of the scenarios, the student will find this easier to implement. So if I do so, this is 4x1 by 3x1 plus 4. This is 4x2 by 3x2 plus 4. Now, once you have written this, all you need to do is cross multiply. And if you do, this becomes 12x1 x2 plus 16x1. This will become 12x1 x2 plus 16x2. And you can see this is getting cancelled out. 16x1 is equal to 16x2, or in simple words, x1 is equal to x2. So now you can see we are getting only one condition when we have solved this, not two. So this becomes a 1 1 function. Earlier when we solved, you can see in this question we were getting two conditions, hence it was not 1 1. Here we are getting only one condition, hence a 1 1 function. Let us move on to the onto part. For finding onto part, we will write x is equal to 4x by 3x plus 4. Cross multiply and find the value of x in terms of y and find the domain of that function. That is simpler to execute. Now if I cross multiply, this is 3xy plus 4y is equal to 4x. So I can write this as 4y is equal to 4x minus 3xy. So it becomes 4y is equal to x into 4 minus 3y. So the value of x in terms of y comes out to be 4y by 4 minus 3y. Now what we are saying is, in order to find domain, it is very simple. Denominator cannot be equal to 0. So 4 minus 3y is not equal to 0. So you can see that y is not equal to 4 by 3. So what is our range in this case? What we are saying, range is any real number, but just do not put 4 by 3 in it. That's it. So this is fine. But now what is given in the question? In the question, they have given the codomain is real numbers. And our range is one less number than that. So our codomain in this question is not equal to range, and hence we will see that this is nothing but an into function. Now in this next question of 2018, what they are saying is basically we need to show that this is neither 1 1 nor on 2. So again, let us break it down into two parts. First is nothing but an 1 1 function. There are multiple techniques. You can also use derivatives, though I have not shown you, and most of the questions you will not find it in the school textbooks also. So I am not using that technique. So now what we are going to do is the most basic technique. F of x1 is equal to f of x2. And if I do this, it is x1 by x1 square plus 1 and x2 by x2 square plus 1. And if I cross multiply x1, x2 square plus x1, it is nothing but x2, x1 square plus x2. And now if I take the terms, similar kind of terms on one side, what I am getting is nothing but this. And once we have got this, I can now factorize it. So in the first part, I can take x1, x2 common. So this is nothing but x2 minus x1 is equal to x2 minus x1. See, so you can see that now we are getting two factors. And this is what I told you earlier also. One factor that will come from here is x2 minus x1 will be equal to 0. Or x1 is equal to x2. So this one is fine. But the problem is that you are getting another answer as well. x1, x2 is equal to 1. That means x1 is equal to 1 by x2. So this is the problem. Now this should not happen. So this is a many one function. If only the first condition happens, then we call this as a 1 1 function. If I move forward, in the second part, what we need to do is find the range. And in order to find the range, we'll again use the same technique. So I will write yx square plus y is equal to x. And yx square minus x plus y is equal to 0. Now see, there are two scenarios. And the first scenario talks about if this is a quadratic. The quadratic will happen when the coefficient of x square is not equal to 0. And we are saying that x is real. So this will only happen when discriminant is nothing but greater than equal to 0. So in this case, it will become minus 1 ka whole square minus 4a and c needs to be greater than equal to 0. So what you can see here is 1 minus 4y square is greater than equal to 0. And if I simplify this condition, that has now come. So I can write this as y square minus 1 by 4 is smaller than equal to 0. So you can see that I can factorize this as y minus 1 by 2, y plus 1 by 2. And if I try and find the answer for this, the value of y will be between minus 1 by 2 to 1 by 2. Now we can check for one more condition when it is not quadratic. When it is not quadratic, you can just put the value of y here. Corresponding to that, x becomes 0. And this is also permissible. What I have done is here I have put y equal to 0. So this is also permissible. There is no problem. So this y equal to 0 we can also use. Okay. So now we can see that based on both of these conditions, the range of the function that we are getting is nothing but minus 1 by 2 to 1 by 2. This range we are getting. But the codomain that is given is nothing but R. So both of them are not matching. So if both of them are not matching, we are going to say that this is not a 1-1 function or a into function. Now this question is directly from NCERT, and this question has been asked multiple times in your school exams. So what happens in this question is, we need to first check out surjective. Surjective is another name for nothing but onto function. And this you should remember because sometimes the question will not write onto. Instead of that, they will write surjective. Similarly, injective is another name for 1-1 function. So sometimes instead of writing 1-1, they will write injective. So you should understand and remember this because sometimes you will get confused in the exam. You will know how to solve the problem, but because of that surjective and injective, you might get confused. So let us say that you got confused in the exam, then do both. So sometimes you might get marks out of that. Now let us see how to do this question. So first let us understand what they're saying. What is happening in this question? What they're saying is it has two parts. The first part will come when you put the values of n as odd. What they mean by this question is, if I put the value of n as odd, that is 1, into this function, it will become 1 plus 1 by 2. That is nothing but 2 by 2 comes out to be 1. But if I put the value of n is even like 2, then this will go in the second part of the function. So this will become 2 by 2 equal to 1. Now let us observe what is happening. Now again, if I put n is equal to 3, it is 3 plus 1 by 2. And you can see that 3 plus 1 by 2 is nothing but 4 by 2. It comes out to be 2. And if I put n equal to 4, it is nothing but again 4 by 2. Again, you can see that similar values are getting repeated. And now, if I keep on doing this, if I put 5 here, then it is nothing but 5 plus 1 by 2, it comes out to be 3. Here, if I put n is equal to 6, again 6 by 2, 3. So you can see that all the natural numbers are coming here also here. They are getting repeated twice. So what we can understand from here? What you can understand from here in simple terms is, one, if I look into my codomain, that is natural numbers. So my range is also coming out to, because every natural number will get covered, and it is coming out to be codomain. That is nothing but natural numbers. So based on this condition, we can say the function is nothing but onto. There is no problem. If in order to check whether it is 1-1 or not, now you can see that if I put n equal to 1, the value came out to be 1 only. And if I put n is equal to 2, corresponding to the same value comes. So many elements are getting mapped to 1. So this becomes many 1 function. So it is not an injective function or a many 1 function. Now this was a very simple way of doing this question. There is nothing very complicated. By putting few values, you can show both the results to be true. Now there is one more way to do the first part of this question. Let us see that method as well. Now this is little bit theoretical, but try and be with me. So what is given in the question is f of n is equal to nothing but n plus 1 by 2 when n is odd. And is n by 2 nothing but when is n is even. So now let us see a theoretical method of doing the question. So now what we are saying is, if I put the value of n as odd would mean 2m plus 1. Now here we are using Euclid's division lemma. But in simple terms, if I put 2m plus 1, if I put any m value, that is any integer, the answer that will be generated is odd. For this first case, that is odd case, and we will use the first part of the function. So this becomes a 2m plus 1. And here m is nothing but any natural number. It is better to put it as 2m minus 1. In this case, will make more sense. So if I put this as 2m minus 1, In place of n, when plus 1 by 2, what you are getting is 2 m by 2. So what you are getting, the answer is m, and m is nothing but a natural number. So you can see that all your codomain got covered. You can further verify by putting another, that is even value, that is 2m. And now if you put this value, your answer comes out to be 2m by 2, answer comes out to be m. And here m is nothing but again a natural number. So you can see that again our codomain and range are coming out to be same. Now this problem type 4 is based on inverse function. Now what is an inverse function? So what we can say is, let us say that now this, let us understand in 2-3 ways. One is in terms of mapping. So if I do this mapping of 1 comma 2 to a comma b, so this is mapping a to b, and we can also map b to a. So now if I reverse this mapping, this is known as nothing but inverse mapping. So now what will happen is, when we put a, I will get my answer as 1. When I put b, I will get my answer as 2. So now the first one, the second mapping that we have got with respect to first mapping would be known as nothing but inverse mapping. So this is nothing but inverse mapping. If I write this in terms of ordered pair, the same thing, we can write it as 1 comma a, 2 comma b. Now we can see that with respect to this will become a comma 1 and 2 comma b and b comma 2. So you can see that in terms of ordered pair, I can do like this. And third, now if it is given in terms of function, let us say that a function is given as 2x plus 3. So instead of this, we will write y. It is nothing but 2x plus 3. So what we are going to do is, in order to get inverse function, we'll express x in terms of y. So if I write it from here, what I'm going to get is nothing but y minus 3 is equal to 2x, or x is nothing but y minus 3 by 2. Now this is my first step. In my second step, what we are going to do is, we are going to replace x by y and y by x. If I do these two things, this becomes nothing but y is equal to x minus 3 by 2. And if I do this, in the third step, I will write this as nothing but f inverse of x is equal to x minus 3 by 2. So these are three different kinds of ways in which we can find inverse function. This also tells us what do we mean by inverse function. Now there are two important things that you need to remember. Inverse function will only exist for bijective function. What does bijective means? 1, 1 on 2. Both the divs are there. So surjective plus injective is bijective. That means 1, 1 on 2 functions. Only in these cases the inverse function will exist. Otherwise they will not exist. And this is the short test as well. And another thing that you need to know is, basically for inverse function, the range and the domain will get interchanged. So whatever was the domain for the first function will become range for the inverse function, and vice versa. Now let us see what kind of question has been asked in the exam. Now you can see that this is given to you. Function they have also given, show that the function is bijective and find the inverse. Now see, bijective part is nothing, the first we will find 1, 1. Now I have shown you this technique multiple times, how to check 1, 1. I've also shown you the technique how to find onto. So first we are going to check this, and if both of them came out to be right, we'll call this as a bijective function. And only then the process of finding inverse will get started. Now in the second part, when you're doing it, what we are saying is, basically find the inverse function. So how to find the inverse function? Write y is equal to 4x plus 3 by 3x plus 4. Cross multiply the terms, find the value of x in terms of y. So if I multiply y 3xy plus 4y is equal to 4x plus 3. What we are getting from here is nothing but 4y minus 3 is equal to 4x minus 3xy. And from here, the value of x comes out to be nothing but 4y minus 3 by 4 minus 3y. So this is what we, and this process is, you can remember, is exactly same as what we are doing in the case of range. So that is the reason when we find the domain of this, it becomes the range of the original function. This is the logic and the reason behind the same as well. Now this was my first step. This is step 1. Now in my step 2, what am I going to do? I am going to replace x by y. So this becomes and y by x. Y is equal to 4x minus 3 by 4 minus 3x. And in the step 3 part, now what we are writing is step 3. We are going to write this as f inverse of x. So it becomes nothing but 4x minus 3 by 4 minus 3x. Now there is also a fourth step, and this step 4 is nothing but writing the definition of the function. So now whatever was written here, you just interchange, because domain will become range and range will become domain. So we can replace this. So we'll write it as nothing but it is mapped from r minus 4 by 3 to r minus 4 by 3. So by using these 4 simple steps, you can find inverse of any function. Now let us look into this 2013 question. What they're saying is this is r plus 4 infinity to this. Again, what they want is to show whether this is invertible or not, and then find inverse. So first let us understand the invertible nature. So now what is happening here is, if I check 1 1, I will put f of x1 is equal to f of x2. This is the first step, find checking 1 1 function. If I put it here, it becomes x1 square plus 4 is equal to x2 square plus 4. 4 and 4 will get cancelled out. So x1 square is equal to x2 square. Now you can see that here it will become plus minus x2. Now here we cannot take a negative sign, because what they're saying is input is always positive. So this cannot become negative. So your answer becomes nothing but x1 is equal to x2. So 1 minus we neglected because of the domain and codomain that were given to us. And therefore in this scenario it has become nothing but 1 1. Similarly, in the next step we can find the range, and from there we will be able to conclude this is onto. I'm not now how to find inverse. We'll write y is equal to x square plus 4. In the first step, express x in terms of y. So y minus 4. So x comes out to be nothing but, see, we can write plus minus y minus 4. But since x is always positive, minus sign will never come. This is what we are getting. In the next part or the next step, we will replace y by x and x by y. And in the next step, we will replace it by nothing but f inverse x is equal to root of x minus 4. And then we'll write the, and how will you write the definition? We'll interchange the value. So 4 comma infinity will write first. And we have changed the order to 4 comma infinity to r plus. So 3 to 4 very simple steps to get the inverse. Before that, check onto and 1 1 in order to check whether it is a bijective function or not. For non-bijective functions, like many 1 onto, like this, or 1 1 into, such kind of functions, or many 1 into, in such kind of functions, your inverse will not exist. Now let us move towards the next problem type. This is nothing but composite function. Now let us first understand what is a composite function and then do question. So composite function means, let us say that fx is equal to x plus 4 and gx is nothing but sin x. So what does composite function means is, if I am writing f of gx, this is also called as fog of x. And what does this fundamentally means is replace this x by gx. So if I, in this x, if I put gx, so this will become nothing but gx plus 4. And gx plus 4 will become nothing but sin x plus 4. This is one. Now if I want to find the value of g of fx, now the reverse process will happen. Wherever we wrote x earlier, now it will be replaced by fx. So what it happens is nothing but sin of x plus 4. And this becomes our answer. So it is a very simple thing. We are replacing x by another function. That is known as composite function. Now this question is given. What they're saying is there are two functions given to you. Find the value of fog gof, then fog of 2, gof of minus 3. It is very simple. So in order to find fog of x or nothing but f of gx, what we can do is, instead of x, we can put gx. So this becomes nothing but gx whole square plus 2. So in this fx, instead of x, we have put gx. Only this much we are doing. So if I, now let us put the value of gx also. So this becomes x upon x minus 1 whole square plus 2. Now they've asked one more thing, find the value of fog of 2. So instead of x, if I want to find fog of 2, instead of x, just let us put 2. So this becomes 2 by 2 minus 1 whole square plus 2. So the answer becomes nothing but 4 plus 2, that is nothing but 6. Now this is a very simple thing that we did in this question. Now let us do the opposite process. Now in the second part, what they're asking is g of fx. So now in this function gx, in place of x, we will write fx, because that is what we have done. So this becomes, and once we have got this, let us put the value of x, fx. So it is nothing but x square plus 2. This is x square plus 2 minus 1. So answer becomes x square plus 2 by x square plus 1. Now what they're asking is the value of gof of minus 3. So instead of x, we'll put the value of minus 3. And if I do so, this becomes nothing but minus 3 whole square plus 2 by minus 3 whole square plus 1. So answer becomes nothing but 9 plus 2, 11. 9 plus 2, 10. 10 by 11. This is what we are getting. Now in order to help you out, what I have done is basically I have included few more questions as a form of homework for your practice. So these questions also you can practice and get a better understanding of the question. Whatever techniques are required at the level of boards I have covered in this video, and largely it will cover important problem types that are asked in the board exams. And largely speaking, if you watched this video lecture from starting to end, you will be easily able to do all the questions in your board exams correctly. I hope it helped you out, and see you in the next one. If you like this video, you will also like Pragbee's unique approach to teaching students or guiding students for the last mile journey. So if you are a student who has been preparing for 2 years and going to write this exam in 2024, this is one of the best ways and platforms that you can prepare with. Unlike other crash courses who focus on teaching 100% syllabus in just 2 to 3 months, which a student took 2 years to prepare, we have a different way to approach the problem. This process works on 3 very specific steps. In step 1, we start from you. What exact preparation have you done in the last 2 years, last 1 year, last few months? And what is the minimum amount of effort, areas, concepts and problems that required to be prepared to get a very good college from JEE Mains? In step 2, based on this customized plan that was prepared based on your strengths and weaknesses and the minimum path of least resistance that you can take to get into a very good college, we align you a one-on-one faculty, a faculty who is going to teach you as a student, keeping your needs into mind, where you are getting stuck in a topic, what kind of problems you cannot solve, and how to solve those problems in a very efficient and smart manner and convert that topic into tangible marks in JEE Mains. In step 3, we attach you to a test series, a testing platform where you can test yourself for each and every topic that you're preparing. You can write full syllabus tests and get an understanding that how this program is working for you, wherein the faculties can again sit with you and customize the plan based on your needs so that your score is getting maximized in JEE Mains exam. Using this program, Ashish was able to maximize his score in JEE Mains and JEE Advanced and was able to get into IIT Madras Mechanical in just a matter of 3 months. If you are one of those students who think that he has got the potential, who can make it, and he wants to have a smart and efficient approach at this point of time, which can maximize his or her result in JEE Mains exam, you can apply for this program in the link given in the description, and somebody from my team will get in touch with you and help you out. See you until next one.